Hello class, in this video we're going to be looking at finding the equation of a parabola. The learning intention for us to do today is to be able to actually find the equation of parabola, so let's get into it. So if you guys are trying to find the quadratic rule for any given parabola, what you need to be able to recognize is the best form for you to actually represent it, and this will be dependent on what information and what coordinates are given to you in the particular problem. Okay, so when you are writing the equation, you're either going to be representing this in the turning point form, or alternatively, you're going to be writing this in the factorized form, okay? The reason why we do not put it in the standard form, which is another way you could actually represent a quadratic equation, is because firstly, that one only tells us what your y-intercept value is, which is the value of c, and not only that, you actually need to have 3 coordinates that's given to you in the question for you to find the values of a as well as b, and then use simultaneous equations, okay? And as you can see, that is quite a lengthy process, so that's the reason why I would avoid using the standard form. Instead, it's a lot more easier for us to represent things in a turning point form or the factorized form. And if the question did want us to represent it in the standard form, then if you did it either in the turning point form or the factorized form, you can therefore expand it to make it look like the standard form, okay? So how do we actually go about this? Well, if the question actually gives you the turning point as well as one additional coordinate, then what you would do is you're going to write the equation in the turning point form, okay? So that's just kind of straightforward. And similarly, if the question gives you 2 x-intercepts as well as another coordinate, and that coordinate could be the y-intercept, it could be the turning point, it could be any other coordinate, then you'd be using the factorized form, okay? And all you simply need to do is follow these steps over here that's outlined down below, and there are a few similarities. So for instance, step 1 for both of them are pretty much very similar. So all you're doing is substituting like the key information that's relevant to each of these forms, so either your turning point or either your x-intercepts. You then substitute another coordinate in, and then what you do is you need to rearrange the equation to solve for a, okay? And that, by doing so, this will therefore give you the complete quadratic rule. I'm going to reiterate, but the most important part for you to understand is for you to be able to recognize which general formula are you going to be using. Are you going to be using the turning point form? Are you going to be using the factorized form? And once you can do this, then it becomes a lot easier afterwards. So what I want to do is I want to give you a few questions, and you're going to have to identify for me which form would you use. So please answer part A, part B, part C, part D, and tell me, are you going to be writing the quadratic rule either in the turning point form or the factorized form? Give yourself 3 minutes and then we'll compare our answers together. Now for part A, guys, if you guys can see by this particular parabola over here, notice that you are already given what the turning point is. So the turning point over here is the origin, which occurs at 0, 0, and you also know one additional coordinate. So therefore, it makes sense for us to use the turning point formula, okay? We're not going to be using the factorized form for this question because you need to know both x-intercepts and you only know one of them. So it makes more sense for us to use the turning point form. For this second equation over here, we are provided with the values of your turning point as one extra coordinate. So again, you're going to be using the turning point form. For the very third example over here, you've been given the x-intercepts and another coordinate, so you're going to be using the factorized form. And for the very last one, you're going to be using the turning point form. Now that you guys are able to recognize which form you're going to be using to write your quadratic rule, let's now look through a complete example of how you could actually generate the rule, okay? So for our very first example over here, you're going to be using the turning point formula because you are provided what the turning point is as well as one additional coordinate. And this was the general formula of the turning point form. So what we're going to do first is we're going to substitute the values of our turning point into this formula over here. So if you do that, if you substitute 0, 3, then this is what your working out step would look like. But as you might know, 0 doesn't really hold any meaning at all, so you can kind of ignore it. So therefore, if you simplified it, then this is what your simplified equation would now look like. What you're going to do now is, because you've got the letter A in this, we're going to need to solve for A by substituting the coordinate that was not substituted so far, okay? So we haven't used -3 and 1, so let's substitute that in. So if you do this, then your equation will now look like this. Find out what is -3 squared, which is in this case equal to positive 9. Move 3 to the other side by subtracting 3. And therefore your equation would be 9a is equal to negative 2. Divide both sides by 9. A is therefore equal to negative 2 and 9. And just substitute the value of a back into this equation over here. And hence this would be the quadratic rule for this particular parabola. Let's now look at another example. And this example over here is a bit different from the previous example because in this case, you are provided with two x-intercepts and an additional coordinate, not the turning point. So therefore, you're going to be using the factorized form when you're trying to generate a quadratic rule. So let's substitute the values of your x-intercepts into this particular general formula. So substitute x is equal to 0 and x is equal to 3, where m and n is. So if you do that, then this is what your rule would now look like. But similarly, 0 has no meaning, so let's ignore that. So this is the simplified equation. We'll now substitute the coordinate that we haven't even used yet. So in this case over here, that's going to be negative 1 and 8. So substitute those values in, and therefore this is what your equation should now look like. Let's now simplify this. So what is negative 1 subtract 3? That's negative 4. And because the numbers are beside each other, this means you need to multiply that. So that will give you positive 4. Divide both sides by 4. Hence, a will equal to positive 2. So again, just substitute that back in here. And therefore, this is going to be your quadratic rule for this particular parabola. All right, guys, since we've gone through two examples already, what I'm going to get you to do now is I'm going to get you to now apply your understanding and see how you guys go. So give yourself 3 minutes to answer this question, and then we'll compare our answers together. All right, guys, for this particular example over here, it's actually quite interesting because notice that in this example, they've provided you with both your x-intercepts as well as your turning point. So you've actually got some flexibility. You can actually use either the turning point formula or you could either use the factorized form, okay? And if you use both of these methods, then you're going to get the correct answer given that you've done the working out correctly. So, but in this example over here, I'm going to show you guys how I would do this using the factorized method since both of my x-intercepts are given. So this is my factorized form over here. I'm going to substitute the values of negative 3 and positive 1 into the values of m and n. And what I'm going to do next is I want to simplify this because two negatives make a positive. So now it's going to become a positive 3. I'll therefore substitute a coordinate that I haven't used yet, which in this case over here is my turning point. So if you substitute that value in, then I'm going to now simplify the equation and then rearrange solve for a. So negative 1 plus 3 is equal to positive 2. Negative 1 subtract 1 is equal to negative 2. So what you do now is multiply these numbers together. That will give you negative 4. So negative 4a is equal to 5. Divide both sides by negative 4. A is equal to negative 5 on 4. And substitute that back into this equation here. Hence, this would be your answer, okay? Let's look at another example. So what I want you to do now is I want you to have a go again at answering this question. Give yourself 3 minutes and then we'll compare our answers. If you guys have done this successfully, then what you should have recognized is that you should have been using the turning point formula to write the quadratic rule for this equation because you are provided with the turning point and you don't actually have any x-intercepts at all. So you can't use the factorized form. So we'll substitute the values of turning point into the quadratic rule. And what we'll do now is we're going to substitute a coordinate in order to solve for a. So you could either substitute this coordinate, which is 0, 6, or you could also substitute this coordinate over here, which is 4 and 6. What I'll do is I'm going to substitute this one over here because ideally you want to choose coordinates that's easy, numbers that contain a 0 or a 1. So in this case over here, I'll substitute that in and I'll just simplify this. So what is negative 2 whole squared? That gives me positive 4. I'm going to move the 2 on the other side by subtracting 2 to both sides of the equation. And therefore divide both sides by 4. A is equal to positive 1. Hence, this would be my equation over here. By this particular stage right now, you guys should start to feel a bit more confident about finding the rule for any given parabola, okay? So what I would like you to do right now in order for you to get a lot more practice is I want you to please answer these questions over here, okay? I don't have the solutions yet, so if you guys could just answer this inside your exercise book and then send me your solutions so that I can actually verify it, okay? But this is pretty much the end of today's video. Hopefully you're able to meet the success criteria of today's lesson. Thank you for watching and I'll see you guys again in the next video. Bye.